Hello everyone, it's Mr. Wolfe here. In this video, I am going to be introducing proportional reasoning when it comes to electricity. The good news is there's really nothing new with proportional reasoning here. We're just applying the skill of proportional reasoning that we've been doing all year to the situation of electricity. And for the most part, there's really nothing new that comes with electricity. So I'm going to work on numbers 2 and 3 in this video, all right? And so for numbers 2 and 3, in his first class, Mr. Wolfe ran the Van de Graaff generator for a long time. A lot of electrons transferred to the conductive dome. In his second class, so this is the new situation, Mr. Wolfe ran the Van de Graaff generator for a long time, and 1/3 of the electrons transferred to the conductive dome. So it looks like 1/3 of the electrons, all right? When I see that, the number of electrons, I know that that's variable n, so I'm just going to start to annotate. And it's going to ask by what factor is the charge on the conductive dome in his second class different from his first class, all right? So if I'm looking for charge, I'm looking for Q, all right? And so right away, if I have number of electrons, Q, I have two equations that I could use, right? And so this one and this one. For proportional reasoning, it could be either of these that you might choose from. And in this case, since these are the variables I have and I don't have force or distance of anything like that, I'm going to use the equation Q equals NE. All right. Now, let's see, for N, that is going to be 1/3 the amount in terms of the number of electrons, right? And it looks like I'm looking for Q. Specifically, though, I'm looking for the factor, right? So how much it changes by. And I need to know E, though, in order to solve for that. Now, E is always 1.6 times 10 to the negative 19th. And so because it's always that number, all right, that is a constant in this case. We don't care about constants. We could just put in a 1, right? It was the same thing when we were doing FG equals MG, and we always know that G is 9.8. And so when we were doing proportional reasoning, since it's always 9.8, we put in a 1. So when we solve for Q here, it's fairly easy math, right? The number of electrons is 1/3 this much. The charge is going to be 1/3 as much. That's it. All right. So that's 1/3 times as much. All right. Now let's apply the factor. So the conductive dome in Mr. Wolfe's class has a charge of negative 3.6 times 10 to the negative 12 coulombs. What's the charge in his second class? So I'm just going to take my original value, 3.6 times 10 to the negative 12 coulombs, times my factor, which is 1/3. And you could feel free to do the math on this, but you should get 1.2 times 10 to the negative 12th. I'm running out of room for my units. That's going to be coulombs. Remember, you could just put C, but I'm going to put coulombs here. Mostly just because I had to write it down underneath. Okay? And that's it. Finding my factor, applying my factor. Okay, so let's look at the next one. Charges A and B, and there's actually an image of it right here, are 0.2 meters apart and experience an electrostatic force of 0.03 newtons. What's the factor? By what factor would the force change? So, I'm looking at what factor would the force change at the end of the day. So right away, I've chosen my equation, right? It's the one with the electric force in it. All right, that's what I'm looking for. Fe. And then my equation K, Q1, Q2, distance squared. All right. Remain while the same, while the charge B changed by a factor of 1/7 and distance changed by a factor of 3. All right, so I have a lot of numbers, right, that are given to me. In this case, right here, right here, right here, right here. Remember, if it has units, this is an actual number, this is an actual number. I'm trying to solve for the factor that the force is going to change, and if I'm solving for a factor, I could only use factors. So it looks like charge B, so we could say that that's charge 2, changed by a factor of 1/7. So I'm going to put 1/7 in right here. Charge A remained the same. So if charge A remained the same, then that's just putting in a 1. All right, and the distance changed by a factor of 3. But remember, that's distance squared, so that's got to be 3 squared. All right. Okay. So then, let's see. K. K is always going to be that 9 times 10 to the 9th. And since it's always going to be that, that's a constant. So I could literally just write it as is, leave it out, or I could put in a 1. Either way, it's fine. But K is going to be just 1, or we forget about it. All right. In this case, I'm going to forget about it. All right. So in terms of solving this, all right, order of operations, I just do my exponent first. So I'm just going to bring these two. So 1 times 1/7 is 1/7. But like I said, exponents first, so 3 squared is going to be 9. So I kind of have this funky fraction right here, all right? So what this is, 1/7 divided by 9, all right? So I'm going to go over here, 1/7 divided by 9, which is just 9 over 1, all right? Now, by the way, you could do this in your calculator, all right? Just kind of do 1 divided by 7, right? And then divided by 9 and get your answer. But let's just say we wanted to solve this, like just on paper, all right? When we're doing this is going back to middle school. 1/7 divided by 9 is the same thing as saying 1, all right, multiplied by the reciprocal. So all I did is 1/7 divided by 9 is the same thing as saying 1/7 times 1/9 here. So then 7 times 9 is just going to be 63, right? So 1 times 1 is 1. So my factor ends up being kind of strange, but this is the correct answer. It's 163 or 1/63 times as much, all right? If you put in your calculator, you'll get this decimal. I'm fine with either one, okay? So what would the new force be? All right. So we know that new force. So I have to figure out what my original force was in this case. All right, so that was 0.03 newtons. I'm not going to worry about the distance. So my original force was 0.03 newtons. I'm going to multiply that by the factor, which is either 1 over 63, or, remember, if you put it in your calculator, all right, we could say that that is 0.016. Let's round it to 0.16. All right, both are the same number. And then that's going to give me a final force of negative 4.8 times 10 to the negative 4. And again, I'm running out of room, newtons. So I'm just going to write out newtons again. You could just put it in as an N if you have room. All right. So in terms of today, working on stuff today, all right, this should be written on the board, all right, in terms of the practice problems that you could do. My recommendation, do 4 of maybe proportional reasoning, do 4 of SCP 5A word problems, but make sure that you do what you need to work on, right? So for instance, right, if proportional reasoning, you're kind of like, I need to help work on that level 2, all right? But if you're like, Mr. Wolfe, I kind of got this, continue with some of these problems right here, right? Level 3, this is level 3, but it's only single step. So how about this? Your goal today is, for SCP-5A, is to work on page 38. Or eventually when we do the formative on Monday, it's going to have some multi-step problems. However, some of those multi-step problems I had taken for our challenge that are at the top. So my recommendation is start at the bottom and you'll get some new, those will be new problems that you haven't seen before. And the key is already online. All right. One other thing that might be helpful, I know it could be frustrating with calculators and everything. So if you need tutorials on just calculator modes or rearranging equations, that's not really a calculator, but it helps to rearrange your equation before putting things in your calculator, or just once you have rearranged, entering stuff in your calculator, some tips and tricks, check out those videos if you need to.